Okay, I'm just going to do a quick video lesson on log properties. So we went through the properties in class last week. Now we're going to apply them. So here it says write as a sum and or a difference of logarithms. So here we could do this really two ways. We could see that when we look at the numerator, so we have a quotient, so we know we want to apply the quotient rule. So the log of a quotient is equal to subtracting the log of the numerator, the log of the numerator is subtracting the log of the denominator. But what I notice here is that this is a quadratic, so, and this can be factored. So I'm going to factor these first. So this would be the log of log base 2, right? This is the base 2, so log base 2. If I factor this numerator, that becomes x minus 3 minus 2, and the denominator has a common term of x, so this is x minus 2. All right. So this factors out, so log base 2 of x minus 3 over x. Using this property here, I can take the log of the numerator, that's equal to log base 2 of x minus 3 minus the log of the denominator, which is x, log base 2 of x. If I didn't reduce first, I could still use the log property. It's still a quotient. I'd still say log base 2 of the numerator is x squared minus 5x plus 6 minus log base 2 of x squared minus 2x. We'd still want to factor this thing. So then I would say this is the log base 2 of x minus 3 times x minus 2 minus, again, if I factor this becomes x times x minus 2, log base 2. All right, let's take this first term. So now I have a product of logs. So I can rewrite this using that if I have the log of a product, okay, I can take the pieces and add them together. All right, so let's rewrite this. So then this becomes the log base 2 of x minus 3 plus the log base 2 of x minus 2. Okay, so I just split this up. I have two pieces. This is my m, this is my n, and so I can split that up where I add those together. Let's look at this second part here. I'm going to write this as minus this whole thing. So this is a product here, right? I have two pieces that I'm multiplying, x times x minus 2. If I apply my log property of a product, okay, it's the log of the pieces added together. So this becomes log base 2 of x plus log base 2 of x minus 2. Okay, if I subtract each one of those, right, I have to distribute that negative sign. This becomes log base 2 of x plus 3 plus log base 2 of x minus 2. I'm going to distribute that negative 1. This is minus log base 2 of x minus log base 2 of x minus 2. Let's see what I have here. I have minus log base 2 plus log base 2 x minus 2. Those things cancel out. And that leaves me here log base 2 of x plus 3 minus log base 2 of x. So I get the same answer whether I reduce before or after? This is my answer. I got the same thing from above here. Okay, let's look at another one. So again, it says use the laws of logarithms to rewrite this whole expression here. And it wants it in this form where I'm going to have some coefficient times the log of x, a coefficient times the log of y, coefficient times the log of z. So that's kind of a hint to us. We know that it should be in this form when we reduce it out. So we have a couple things going on. We have a quotient. So I know I'm going to use this quotient, and then I notice that I also have powers here, right? So I'm going to also want to use this log property down here. Okay, these two. So let's take care of the quotient first. Let's rewrite the quotient as log of, we can subtract the log of the numerator minus the log of the denominator. So let's write the log of the numerator is x to the 14th times y to the 6th minus log of the denominator, which is z to the 12th. That's a z. All right, so now look at what I have. I'm multiplying two things, x to the 14th times y to the 6th. So now I'm going to need to use the product property here. So when I have the log of a product that is equal to the addition of both those pieces, I'm going to rewrite this first term as the log of x to the 14th plus the log of y to the 6th minus log of z to the 12th. All right, now I just have a string of power functions, x to the 14th, y to the 6th, z to the 12th. Now I'm going to use this step on all of them to finish it out. So what this says is that if I have some number raised to a power, I can say that's the power times the log of whatever the base is times that m. All right, let's rewrite this. So this 14 comes out to the front. I have 14 log of x plus that 6 comes out to the front plus 6 log of y, and this 12 comes out to the front minus 12 log of z. And so now we can see each of those has a coefficient, 14 times log of x, 6 times log of y, minus 12 times log of z. That's exactly in the form that we want. You can see above. So here's my log. So a is 14, b is 6, c is negative 12. All right, let's look at another one. Okay, so I'm going to scan this and say, what do I have? Well, my base is 3, but then I have the log of x to the 10th times, okay, the cube root of y to the 18th. So the first thing I'm going to do is I'm going to rewrite this term here. I know that I can rewrite this as y to the 18th over 3. All right, so whenever I have something in a radical y to the n and the m, I can rewrite that as y to the m over n. This thing always becomes the denominator. This thing comes the numerator. All right, so I rewrote that. Let's rewrite the whole thing down below. Log base 3 of x to the 10th times y to the 18th over 3. Okay, so this is a product, the log of a product. So I'm going to use this here. I'm going to split it up and add those pieces. So this becomes the log base 3 of x to the 10th plus the log of y. And in fact, 18 divided by 3 is just y to the 6th. right? I'm not done yet. I have a final log property. When I have something raised to a power, I take that power on the outside and take the log of that base. So this becomes then, I have a power here that can be pulled out to the front. So I have 10 log base 3 of x. I have a power here that can come out to the front, plus 6 times log 6 log base 3 of y. All right, that is the form that we wanted in. Okay, we want a times log of x, so a is 10, and then we have b times log of y, and so all it wanted us to put in was 10 and 6. And then let's do this last one. So we're really focusing here on these log properties, all right? So we know that when we have the natural log, that really means we have a base e. So log, natural log base e to the negative fifth is equal to, we know if we take the base raised to this x value, okay, is equal to this whole thing here. So we can say e to the x is equal to e to the negative 5, meaning x equals negative 5. Okay, that's equal to e to the negative 5. Okay, e to the ln of 7. All right, well, that's this here. It's just that our base is e. We can say e to the ln of x is just equal to x. These are the same, just this has the natural log versus b. So this is just 7. Here again, we have e to the ln of square root of 3. E to the ln of x is just equal to x. This is just square root of 3. And then if we do this last one down here, I have ln of 1 over e cubed. Let's rewrite that as the natural log of e to the negative 3rd power. Okay, this is base e. E to what power is equal to e to the negative 3rd? That's just e to the negative 3rd equals e to the negative 3rd. So this is negative 3.